What else? Done with this element, the only thing is remaining is sum forces on x equals 0. On x, Cx is positive, negative BD 225 sine alpha equals 0, or Cx equal. What is Cx?
120. 120.
101.
120. 120.
0.
120.
Why here 1, 1? 1, 2, 0. And the last one, sum of forces on y equals 0. I have Cy is positive, negative 400, negative BD 225. Cosine of 28 degrees equals 0. And from here, Cy equal
625.
225?
6.
625. So what we did in here, we eliminated the element BD, assuming the direction of the force, that's all, and dealing with the rest of it. In this situation, we solve the problem by making, instead of having 4 unknowns here, we switch here to have 3 unknowns here. Make sense?
So when the book says the component singular of the reaction at C, is that a typo and it means the components?
The problem 76, determine BD and the components of the reaction at C. In real life, there is no CXCY. In real life,
Oh, okay.
we got here
Then I would just say
CX,
the reaction is C.
CX is 120, CY
Yeah.
625. This is the reaction at C. We break it for you to make your life easier.
Sure. But then you just call it the reaction at C.
We
not
call it the
component.
components. The components of the reaction at C.
Never
The
mind.
CXCY.
It is just a typo. If you look at all the
I
other
think it's a
questions,
typo.
it has components plural.
Is it what you're talking
There's
about?
no S. after
No S?
Probably just a typo.
Components. Okay. What do you think of this frame? What do you think of the frame?
I think it's great.
Okay. I would like to do one more problem from these pages. And what about this one? We did 76. From this stage, which one do you think we should do? 81, 82, 77, 78, 79, 75?
81.
81. Question 81.
That 77 looks cool with the balls in it. They're rollers, you know, they just got the one reaction.
This is one piece. Can you see it? This one piece? Then we have this one, piece number 2. Then we have this one, piece number 3. Then we have a force here, 150 at theta. and we have pin here and pin here.
What are pins?
This is A, B, C, D, E, F. And dimensions in here is 250. 200 here, 50 here, 100, 300, 100. Here, 300 here, 100 millimeter here. Let's see if we need shade on. So questions, find the components of the force acting on member A, B, C, D when theta is 0. A, B, C, D. A, B, C, D. What is the element? We know that A and B are pins. Pins means for unknowns, for forces, correct? So what is the element that I should think of me is going to help me? What element do you think is going to help me? Between these, we said that we have 3 elements that we need to dismantle them in order to solve the problem. So we have here, if I dismantle, I have this one here. This one is long like this. I have this one in here. And I have this one in here. Is this how you dismantle it, correct? But before you dismantle it and start drawing, which one of these could help me to eliminate some of unknowns? Which element? B, D, E. E, D, D, E, correct? D, E is enclosed between 2 elements. So the reaction in D, E is going to be from D to E, or from E to D, correct? If we got this, then which element to deal with?
On the right.
The one on the right. Why? Because if I deal with this, I have 2 unknowns, I need to add it another one and 2 unknowns here, correct? So I need to deal with the one on the right. Is everybody understood how we did this? Everybody? So the one on the right, which it is this one here, like this, this one has these reactions here, CY, CX, this is E, and this is 0, 150 Newton. How I should write E? From D to E. That's all the reaction, DE. That's all. One reaction. You don't have XY component. It could be if this was a little bit to this angle, then you have XY component for DE, correct? From this one, what I should do?
Calculate the moment at C.
Moment at C. Some moment at C equals 0. I have 150 is negative times this distance 400.
Excuse me?
Yes.
How is the 150 newtons facing straight down?
Because it says when theta equals 0.
Oh, I'm sorry.
If you read the question in the book, that's why I asked you guys to bring your book with you.
Oh, okay.
Sum of the moment, DE times 300 is positive equals 0. From here, DE equal 200. Right? Agree? Sum of forces on X, sum of forces on Y. Sum forces on X equals 0, CX equals 0. Correct? Sum forces on Y equals 0. We have 200 is hitting up, 150 is hitting down, CY is hitting up, equals 0. CY equal 150 with 200, there is 50 positive, negative 50. Correct? Negative 50 means here CY. The real CY is here. CY equal 50 Newton in this direction. This is very important to fix it in here before you move.
Yeah.
DE, opposite direction, 200. CY is 50. Agree on these two forces. Now acting on this member. B, Y, BX, AX, AY. Can you see that? Can you see how I move the forces from the element to the left, to the right, to the element to the left? And this is very important. We get a negative, change it, show it to yourself. You need to visualize it that this is now hitting down in order to see that here is hitting up. Sum of the moment, he said that A equals 0. Here is A. I have BX times. The height is 200. Is negative. Agree? The CY times 100 is positive. The DY times 400 is negative. Equals 0. CY and DY, we know them from previous shape. We got BX here equal. How much? 375. Sum forces on X equals 0. AX equal negative 375 Newton. Agree? Here is the final answer for AX. Everybody. Sum.
I think BX should be negative and AX should be positive. I just did secondary.
Then here, go back to this equation. Negative BX. This is negative here. This is negative BX times 200. This is CY times 100. CY is 50.
So 5,000.
5,000. BY is 200 times 400 is negative.
I think the distance
So this
for
is
NY
negative.
Well, and you define CY.
This is positive.
So negative.
Yeah, projection switch.
Oh, right.
So this is this direction, and this is
Makes
BX.
sense.
This
So it's gonna be
direction.
Pulling it off the wallet. And into the wallet.
What is remaining here? Sum of forces on Y is going to give you 200. Sum forces on Y equals 0. I have 50 is positive, 200 is negative, Vy is positive, and Ay is positive, equals 0. Ay, I think is 0.
Yeah, it's on a roller.
You will ask me why.
Yeah. It's on a roller.
It's a roller. It's going like this. And even if it's not a roller, it's still equals 0 because, look, even if it is pinned, when you pull something like this and it's fixing here, this one down here can work just like this, just pushing on it, the lower side. And from here, By equal 150. What do you think? What do you think of the frames?
Not bad.
Do you need another example on the frames? Good. When we deal with the frames, this is will lead us to deal. We still have time. It's not fun to keep sending you home early, no? And especially Monday, I'm sending you at 7 home. So, this is will lead to the machines. Machines are similar to what we did in here. All what we need to do is to dismantle it piece by piece. And let's start with a problem that was in the test. Problem between 122 and 123. Both of them are the same principles. Or we can go to 148, or 146, or 147. I'm telling you, these problems were in the test. The ones that when I suggested you, some of them, they were 155 was in the test. 145, you choose. 139. Yeah, guys, go select. We will. Next week we are going to spend only 1 more hour on these machines. So today we need to solve one of these machines. Select one. Select. Forget about the names I said.
145?
He said 145. Okay with you guys, 145?
Yeah.
Okay, let's see 145. 145. 145. Find the magnitude of the gripping forces produced when the 300 force are applied as shown. So, in your test, don't bother to draw this picture again, the whole picture. You go draw your free body diagram out of it. You look at it and you will see, do you know what? I have this element here. I have this part down here. I have this part down here. Or I have this part. Looks like this. Is it the forces? Are these the elements that are in here?
Yeah, it looks like it.
Okay, so this is here A.
Pretty big diagram.
This is here B. This is here B and D. This is here D. This is here C. We have a reaction here, a gripping. The gripping force. Dimensions. 12 millimeters here. 120 here. 36 here. Go to this one here. This one here is 96. This one is 30. This one here is 42. Between these two, I have 6 millimeters here. Look, between this one and this one here, I have 6 millimeters. And then I have 30 from A to the other. Let's leave the 30 later on. From what we see in here, 4 pieces of metal that I dismantled that thing, that device, where I should start. Let me just write the names A, B, C, D before we. A, B, C, D in here. Lower side C. This is A, C. Everything else
That
is
is a force.
done.
Yeah.
Which element I should start with?
C to D.
C,
And D.
D.
Yep.
So if I start with this element here, CD, it is this one here. Something like that. I have here AC. And I have here dy dx. I have here 300. Can you see it now? Like this. Everybody?
Yeah.
From this one, if I calculate some of the moment at point D, here is D, to get rid of these 2 elements, some moment at D equals 0. I have AC. Before AC, let's calculate
Alpha.
the.
Why wouldn't you take the moment at C?
What's that?
Why wouldn't you take the moment at C?
I have two unknowns, the x and dy.
Eliminate the number of unknowns.
So it is, I need to get rid of two unknowns. If I calculate the moment at d, I get this guy directly. It's easier. Then sum of force in x, sum of force in y to get them. If I start sum of moment here, I have two equations, two unknowns. Then I need to do sum of the x's. I have these two. Then sum of y's, I have these two. So I need to write the three equations in order to, then I need to write the moment. So it's easier to do it in here. This distance here is giving in your book as how much? 30, correct?
Yes.
And this distance here from C to A is what?
84.
C to A, if I add this 48, 168,
Or you can just do 96
No.
minus 12.
156, are these on the same line? They are not on the same line.
96 minus 12.
So you need to go 120 plus 36 is 156. Minus 30 minus 42. Correct? 72 out of 156.
84.
Agree? Everybody?
Yes.
So this distance here, we calculated it as 84. Then this here alpha,
19.7.
19.7.
30 over 84. 19.7?
Yep.
19.7 degrees. This 19.7 is right in here, from horizontal line. So, let's write down some of them on AC. Cosine of 19.7 times what? Times 6 is going to be negative. Agree? AC sine of 19.7 times 30 is going to be positive. 300
26.
times 126 is negative equals 0. One equation with one unknown. What is AC? Plug it in your calculator. What?
4.5.
425?
4.5.
I'm doubting myself.
4.5.
Highly doubting that's not right.
That's almost 0.
Yeah, I'm good.
Other answers? Okay. Do we need to do sum of forces next, sum of forces on y? Do we need it?
I got 8468. Or 84, yeah,
84?
8468.
84.68?
Boy, 8467.68 if you want to keep it on that for.
8,467 Newton.
Okay.
And
What?
Yeah.
That much? It's a big rubber on there.
okay. Do I need now to calculate sum of forces next, sum of forces on y to get dx dy? I can. Let's look at it. I can calculate now sum of forces on x equals 0, sum of forces on y equals 0. What I get from these two equations? I get dx equal, I got here dy equal, correct? Then I can go apply them at this one. Dx, dy, calculate the moment at B, I get the GF. Or, I be smarter. I don't care about the components of the force at each pin. The question asks me find the GF, the gripping force. So I go to the top force now. I apply here a C that I just calculated. I know this, I calculate this. I talk too fast at people.
No, it makes sense.
One more time.
Yeah.
Okay, slow down. If I calculate sum of forces on x, sum of forces on y from this element here, I can apply them at this little element here, correct? dx and dy, correct? I calculate sum of the moment at b, because I don't need to worry about reaction at b, x, dy, correct? And in this case will give me GF. Agree? Equal. Do you agree? Or I don't need to do that. I go to the upper side, I calculate AC. I know this, I calculate sum of the moment at B for this upper side. Agree? Equals 0. So let's look at this side here. Before we look that, we put this force AC, and he said it's 8,467, and his down means it's hitting up with 8,467. And sum of the moment at B equals 0. I have 300 times 132. Can you see that? It's positive. Correct? AC, which it is 8, 4, 6, 7.
It was 84.67, right?
What's that? This one, sine of the angle, 19.7. 120 is positive, negative? Negative. What else? What about this 8, 4, 6, 7 cosine of the angle?
It's on the same line as B.
It's going to be on the same line. It's not going to produce any moment, correct? And the GF, the gripping force, times 36. Positive, negative? Positive. Equals 0. One equation with one unknown, GF equal. GF. Any answer?
Newtons.
Look what we did. You grab the player and you put on it at 300. You get at the other end 8,400. This is what we call it mechanical advantage. The mechanical advantage equal the outcome force over the end force. Give me a number.
Only applying 600 newtons to it though, because it's 300 on each side.
Yeah, but you're also applying 84-14 on each side.
84-14 on each side,
Oh, okay.
28.
28.
28
Which
times
means
28
Each
to 1.
bound or each neuter, you put it at one end, you get it at the other end 28 more. If you go to this bolt cutter, which it is way bigger than that bolt cutter, on the following page, because of the handle is too long, the mechanical advantage is supposed to be more than 150, 160 times. So if you put 20 pounds at the end, you'll get a 3,000 on the other end or something like that. Questions on this? Do you want one more question on a small machine? You can do it in 10 minutes if you
He's
want.
looking at the clock.
Okay, select one. Select one. Even if you stay 10 minutes more.